For this third video now, it says carbon monoxide is reacting with steam to produce carbon dioxide and hydrogen gas. So how were you able to work through that that reaction? So carbon monoxide gas reacts with steam, which is H2O gas, to produce carbon dioxide and hydrogen gas. Remember, hydrogen gas is H2 because of Hunkelbreath. Let's check it out. We got one carbon, one carbon. It mentions equilibrium, so I should get a double arrow here. We have 1, 2 oxygens, 1, 2 oxygens, 2 hydrogens, 2 hydrogens. This one's nicely balanced with all these 1 mole ratios. And it says our K is equal to 5.10. It says the equilibrium constant is 5.1. Again, that 700 K, I'm trying to kind of trick you here a little bit. It doesn't, that temperature is not, it's a factor on the equilibriums, but it's not going to affect the math at all. Okay, so this is an ice table problem because it again is asking for what are the equilibrium concentrations, blah, blah, blah. So I like to get my ice table set up. We're going to break it down into each species here. So the CO, the H2O, the CO2, and the H2. Now we're going to read this, and it says we have 1 mole of each mixed together in a 2-liter container. So it looks like these are all 1/2 0.5 molar. And since this one's just giving moles and liters, I would just put it in molar and just leave it as that, even though they're gases. Now, since we have values for each of these, we need to think about what's going to happen. So Q equals the concentration of products divided by the concentration of reactants. That's going to equal 0.5 times 0.5 divided by 0.5 times 0.5. That's going to equal 1. So it looks like my Q value is 1 and my K value is 5.1. So this is going to help us decide the direction of that the equilibrium will shift. So since K is greater than Q, this reaction is going to favor that forward reaction for a bit until we reach equilibrium. So that means that the CO2 is going to go up, so that can be plus X, and it's 1X because the mole ratio is 1 again. The H2 will also be plus X. And if the products are going up because the reaction is shifting to the right, that means the reactants must go down. Now this one looks like it's going to be obnoxious, but we'll see in a little bit why it's not that bad. So this is going to be 0.5 minus X, 0.5 minus X, 0.5 plus X, and 0.5 plus X. Once we have our equilibrium concentrations all set up with the X values, we've got to plug it into the K expression. So K was 5.1. Now my concentration of products. What's 0.5 plus X times 0.5 plus X? Hopefully we're getting 0.5 plus X squared. And you know, you could write out 0.5 plus X times 0.5 plus X and then combine them to this. I just kind of did that in my head. Now again, on the reactant side, we have 0.5 minus X times 0.5 minus X, and we just get 0.5 minus X squared. Now, think back to the first page. The 2 tricks we will use for these types of problems. We're either going to take the square root of everything, or we're going to get rid of the minus X or plus X. Now, if we got rid of both of these plus minus X's, we wouldn't have anything to solve for. So again, that's probably not going to be it. Could we take the square root of a number? Yes. Can we take the square root of 0.5 plus X squared? Sure. Can we take the square root of 0.5 minus X? Yep. That means we're going to do the trick where we take the square root of everything here. Now let's put the square root of 5.1, and that's 2.26 about. This is going to equal 0.5 plus X over 0.5 minus X. Now if we want to solve for this problem, we got to do 0.5 times 2.26 to get 1.13 minus 2.26X is equal to 0.5 plus X. I'm going to kind of go up over here. So now we gotta combine like terms, and 1.13 minus 0.5 is 0.63. And if we add 2.26x to both sides, we get equal to 3.26x. Now divide both sides by 3.26 and we get x equals about 0.2. You could stick with the 0.19, I guess, but I'm trying to just not use sig figs too much with this work. So we get that 0.19. X equals 0.2, and then we just got to plug it in these four situations. So what's 0.5 minus 0.2? 0.3 molar. 0.5 minus 0.2? 0.3 molar. 0.5 plus 0.2? 0.7 molar. 0.5 plus 0.2? 0.7 molar. And this is how we plug the X value into our equilibrium concentration values with X to find what are the equilibrium concentrations.